们现在正式到达了 Chris Reeve 的工厂。今天呢，也是非常荣幸请到了 Chris Reeve 这个刀具品牌它的创始人和老板他的儿子 Tim Reeve 来为我们进行一个快速的工厂的 tour。那么在进去工厂见到 Tim 开始 tour 之前呢，我想快速跟大家讲一下 Chris Reeve Knife 这个品牌传奇的历史。那么在2000年的早期呢，应该是2002年，美国陆军特种部队绿色贝雷帽这支部队啊，决定给每一个通过陆军特种部队选拔 Q Course 的人赠予一把叫做 Yarborough 的刀。为什么要叫 Yarborough 呢？这个名字来自于 William Yarborough 这个人。Yarborough 这个人呢，他被誉为美国特种部队之父。正是在 Yarborough 这个人的带领和推动下，美国才有了像绿色贝雷帽跟三角洲特种部队这样的精英特种部队。而从2000年初期一直到今天，所有的 Yarborough Knife 呢，全部出自于这个 Chris Reeve 的刀厂。在 Chris Reeve 的旗下有一款 fixed blade， 就是固定刃的刀，叫做 Green Beret。我胸口别的一把枪边上的那把刀就是同款的 Green Beret。Green Beret 和 Yarborough 本质上其实是同一把刀，它从质量、材料、形状设计等等一系列指标上，与绿色贝雷帽成员持有的 Yarborough 的刀呢是完全一样的。唯一的区别呢，就是 Yarborough 上边会印有 Yarborough 的字样，以及每一把 Yarborough 刀上面都有自己的序列号，来彰显这把刀主人的特殊的地位与荣耀。OK， 那让我们进入工厂，找到 Tim， 开始我们的 tour。
Came at a funny time because I've got a shop on this side and then we've got a shop across the street. So that a lot of over there is the manufacturing side. About 18,000 square feet over there, about 6,400 square feet on this side.
So that's the primary manufacturing facility.
Yeah, so all the milling, turning, grinding, fabrication, all of that's over there. So raw material comes in over there, and then we'll machine parts, and then they'll come over here. We'll do all the finishing and the fitting and sharpening, all that kind of stuff, and then obviously front of the house stuff. Yeah, right now I have across the street I have like a big, huge, brand new 5-axis machine coming in with a pallet pool, and we got machines moving around, and the lathe and stuff. So I'll take you across the street, but it's kind of a mess over there. A lot of the raw material comes in over there, so when we get over there, I'll kind of show you what that looks like.
Powdered metals will always be forged, I guess, or melted by the steel manufacturer, because if it's in powder, it's not steel yet.
Yep.
And so they'll do that. That's a massive facility. That's like a whole nother company to do that.
Yep.
And then they'll get it into a sheet for us, and then we'll go from there. Now, we're part of the stock removal type knife makers, if you will. Then the other side would be like blacksmiths. And that's where we call them the Hammers and Sparks boys.
Yep.
I've got a lot of blacksmith friends, and they're great. Learn a lot from them, but we just have different processes. So they'll take a smaller piece of steel and then heat it up and forge it and hammer it and stretch it out into the shape that they're getting at, and then do any sort of finish grinding. So it's a bit of a different process where we're going to take that oversized steel and cut away till we get there. They're going to take generally an undersized piece of steel and stretch it out to that. It's loosely a way to put it. I'll probably have a blacksmith friend give me a hard time about that description. So I don't have any of the GBs or Pacifics on hand right now and what the blank looks like, but this is our backpacker, same kind of process. So we have them either water jet or laser cut, kind of depending on the product. This profile, it's a 40 thousandths near net profile. So that means it's 40 thousandths bigger all the way around than what the finished size will be. And then it's oversized here. That'll have the mill scale. And so the first step that we'll do is surface grind it and take off that mill scale and get into kind of the meat of the material. When it comes to like micarta, we have sheets of micarta here. We have blocks like this is Macassar ebony for cutting inlays, wood inlays for the folding knives, stuff like that.
So we'll bring it down to size. It'll go to the milling machine, and then it'll go out to heat treat, come back, get heat treated. We'll impact peen to get it straightened out, and then we can hollow grind. Then it goes across the street, laser, swedge, sandblast, paint, sharpen. Got it. And then assembly. The very first step of those blades start right here, and he's actually grinding Green Berets right now. So this is finished grinding folder blade. So this is after heat treat. We take 1/4 thou per side off the blade, getting down to a plus or minus 1/10 of a thou overall thickness. It's just making them very accurate, very consistent. The more accurate we can make it, like all the steps leading up, if you keep and hold that accuracy, when you go to bevel grind, you can get those bevels on there much more accurately so that they're more symmetrical, but the edge thickness stays the same, that kind of stuff. These pallets right here, they have locators on the bottom, precision locators. And we'll place those in here. They'll receive into that hole. You see the ball bearings? And then you'll have air, pneumatic air we'll lock those ball bearings in and lock that pallet in place. Relocates within a few tenths of a thousandth of an inch. And then we can come in and profile. So every product has an A and B pallet. So say you had your A pallet in there and it's machining, you can be unloading, reloading, measuring the parts off of your B pallet and know what kind of offsets you need to put into the machine. And then quick change, pull the A out, put the B in, and ready to go. So pretty much every one of our products is set up like that. You'll have a program, the tooling, and then an A and B pallet for it. And then the handles, the micarta handles, he's over here. So we'll take one of those big sheets of micarta, we'll chop it into blocks. He's just kind of deburring it a little bit. And then he'll put them on to a pallet like this. We'll lock those blocks in there and it'll do the underside, like semi-profile it, drill the holes, and then it'll come over to here on Op2 and we'll hold it by the holes. And then we can do all that 3D contouring, the surfacing. Now you have like a three-dimensional part. Maybe kind of hard to see, but so we use a coolant. One, it keeps the tool and the part cool, but it also flushes out any of the chips out of the cut.
These have been machined. The profiles have been machined, and it's been surface ground to thickness. And these are getting ready to go out to heat treat. So our heat treater is just down the road. It's an ACECO, and they've got a big industrial heat treat outfit. We used to do all of our heat treat in-house, but as we moved into the CPM steels and higher volume and things like that, we're very lucky to have ACECO just down the road. I know Ken Barker, the head of the heat treat department, pretty well, and he's not only a metallurgist, but he's also kind of a knife nerd. So when we have new steels come out like MagnaCut or any of these, I can always go get with him, and we can kind of nerd out together and figure out like what is the heat treat supposed to look like, what's the curve look like, all that. If we didn't have ACECO, I'd be showing you like a big multi-million-dollar heat treat outfit. But luckily, I don't have to invest in that, and I still have that really close relationship with the heat treater, because that process is very important. This is Cece. She's our production manager.
Production manager.
This is our Rockwell hardness tester. So we've literally never had a problem from ACECO having the wrong hardness, because they always test one or two out of any batch coming back to us. But whenever we get stuff back, we still test it anyway, just to double check. Yep. And so if there's ever a knife that has like it doesn't in question, we can always just test it right here. So yeah, heat treat's a very important part of the blade. Something we take very seriously. And yeah, so that's how we can test it. All right, come on.
So this is another step in the fixed blades. This is the hollow grinding of the fixed blades. So yeah, so that's one that went wrong. If you get everything wrong, you can burn the blade. So that's what that brown mark is. So we make sure that we don't do that. So that's a scrap part right there. But the blades will come in. These are back from heat treat. We've impact peened them just to get it to settle down and straighten out a little bit. And then we'll come in and hollow grind the bevels. This just hollow grinds Green Berets and Pacifics all the time. So this is a milling machine with an auto pallet changer. So you can see the B pallet is out. So on the left side, we have Op1 and Op2 of the hollow grinding for Green Berets, and then we'll have Op1, Op2 for Pacifics over here. So every time it goes in, it'll cut 4 bevels, and then Op1s, when it comes out, Op1s go to Op2, and Op2s come off the machine. So this is the grinding wheel that we use, and you can see those are freshly ground bevels right there. It's always nice when you can put the hollow grind on there, because it really starts to look like a knife at that point. Yeah, I always like that. So yeah. So that's what that machine does. This is an old 1997 Matsura that we've had for ages. And man, we've gotten our money's worth out of it. It's a good old machine, but we're also kind of waiting for the day that it dies. It could get a new one. It could go any day. So that's why that new 5-axis came in. I'll show you that in a second. So this is grinding bevels. You can see the tool where it's all splashing out. That's what's called a CBN cup wheel. CBN stands for cubic boron nitride. Basically think of diamond and then like one step below that. You can see in there, there's Op1 and Op2 in 4 different stations of folding knife blades. And we'll come in and see it'll rotate to the next op. It's coming down here. It's a process called dressing. So it's just cleaning the stone, basically, taking any impregnated blade steel out of the wheel, out of the stone. It's a little dressing process. And then it's going to go back. Yeah, so you have Op1 and Op2. So every time it cycles the whole or finishes a blade, you got 4 completed knives coming off. And then he's loading pallet B right now. So He's pulled off the op2s that are good. He's going to measure, make sure things are consistent, and then he's going to move the op1s into op2, and then put new blades on for op1. So you can see op1 right here. That's that full thickness. And then op2, we use as support because, you know, we've ground that off. We're going to put it belly down. So we need some sort of support for the non-full thickness side.
Yep. So this one, it carves exactly the same as the one that you shaved off, right?
Yep.
Nice.
So that's kind of the grinding department. We can go into the other big machine shop here, and I'll show you more. This will be kind of like hardware and folding knife related stuff, but yeah, it's the rest of the machine shop. I'll show you the 5-axis. So this is our Swiss lathe department where we make all of our hardware, all the screws and pins, back spacers, pivot bushings, all that stuff, the thumb lugs, everything. So yeah, these are small Sebenza stop pins right there. So we make them out of a material. It's a pre-hardened 17-4. Buy the bar stock in a 12-foot length. It comes in a condition called TGP. This is turn ground polish. So they'll turn it to a diameter, grind it to a finer diameter, and then polish it to an even finer diameter. So over a 12-foot bar, you're looking at maybe just a few tenths of a thou variance in diameter over the whole bar, which is crucial for the Swiss machines. Yeah, it's really nice to be able to make everything in-house. It's quality control. It's if you have to make quick iterations or design changes, things like that, you can just do it right here. So it's been really nice. You can prove out different materials if you needed, different designs. So yeah, we have 5 different Swiss machines just making hardware. These machines here are the folding knife handles, so titanium handles. So you can see Umnumzans. Those are left-handed Sebenzas. Yeah, so this is a milling machine. It's called a horizontal. So basically, a lot of folks are familiar with a conventional milling machine where your spindle comes down. That's your Z-axis, and your table moves in X and Y. This is like turning it all on its side. So you have the horizontal, the spindle's on its side. It's going to move in X and Y. And then this fixture, or what's commonly known as a tombstone, moves in the Z-axis and then has a 4th axis that it can rotate in B. We just use that to clock from face to face. This machine has a pallet pool, so it actually has 5 of these tombstones available. It takes about 10 hours, 10 to 12 hours, depending on what the product is, to finish all 4 sides of a tombstone. And so this has 50 hours of unmanned cycle time, basically. So you can program it that it'll do the one pallet, and then it'll pallet change and go on to the next pallet and do all that. So essentially, I have a whole, over 40 hours of a work week worth of machining time here, and like a whole weekend as well. So yeah, it's pretty awesome. You see that tool chamber back there? That gray box is a tool chamber. There's 240 available tools. So that could be all the end mills that profile, chamfer, engrave, down to like really small end mills like that. That's a 40 thousandths diameter end mill that we use for slitting the lock arm. So that's for engraving, or for cutting that feature right there, slitting that open. So this is just making large and small right-handed pocketed Sebenza handles. We've got op1, 2, and 3. The blade blanks are the same as the titanium handle blanks. It's a 40 thousandths near net shape. You get them from Niagara Specialty Metals out in Buffalo, and we'll throw them up here. So op1, we're going to drill the holes, which is your datums, your locators, and then we'll move it, hold it by the holes in op2, and do most of the profiling. And then op3, we flip it belly out, and that's where we'll split the lock and do the inside engraving, stuff like that. So you can see handles right here. You got a little date stamp. With the folders, we just kind of use this for a little bit of tracking. So we just do the A, B, C, D for the quarter, and then the year. If there's ever a problem with the folder, say the lock mechanism or something like that, we could track it back if we needed to. You can see we're running Umnumzans on there. So op1's been done. He's drilled the holes. He's going to move those to here, hold it by the holes, and then flip it belly out.
Yeah, this is the end of the line. So this is a bit bench right here. So all the folders will come through these guys. We use the surface grinder. This is for cutting the lock mechanism of the blade. So we have a fixture right here, and the blade would go tip down and then lock in. So the back end of the lock face will be right here. So when the blades show up, they're 90 degrees square like that. And then when on that fixture, we can come in and grind that bevel that allows that lock to function, right? Okay. So as you open the knife, it comes over, so you have to create a bevel. Now, why we use a surface grinder is it's very repeatable and very accurate, you can make very like small adjustments. So say you cut the lock, you come over here, you put it together, the lock's a little bit early. You can put that blade back on, take off like a half thou or a thou, and then it usually jumps right where you need it. We've got a laser laser engraving department over here, so we do a lot of like little customizations, little naming and engravings, company logos, things like that. For the military knives, we do all like the CR Harsey and then the Idaho made CPM Magna Cut. Yeah, so sandblast, coat, and then sharpen after that. Handles get installed, and then out the door. Start tumbling department for the folding knife blades. That's where we'll get this this nice like stonewash finish.
Oh, I see.
Yeah. The blade will come in looking like this from hollow grind. Got surface grinding marks going this way, hollow grinding marks going that way. It's all kind of rough and unfinished. The first thing they'll do is come through and hand stone the blade, and then they'll work the plunge. Usually we get a little bit of stepping and grind marks in that plunge area. So you can see what he's doing there. He's using a pneumatic finishing tool. He's working out, taking any sort of chatter or grinding marks out of the plunge. Then we'll run them through the different tumblers. That's our finished tumbler. This is our rough tumbler. And so we'll get, basically it's two patterns of scratches on top of each other. There's like a rough pattern and then a finishing pattern. And then you get to this nice kind of silky smooth. We sandblast all of our handles, but the problem with sandblasting blades is unless it's coated, you're gonna start pitting the steel and you can start opening up corrosion problems. With the fixed blades, it's not a big deal because we sandblast 100% of the steel, but then we go in and coat the blade with the Cerakote, which is a non-porous coating that'll keep moisture out. Obviously you're gonna have your exposed edge, but with a polished edge, it's not gonna take on corrosion like a pitted sandblasted edge. It's not exposed like sandblast.
Got it.
So like I said, after the laser step, the blades will come into here. They're not profiling any or swedging any right now, but basically that's that same kind of feature you were asking about. We'll grind that out, put the wedge on either side. Usually we'll set up this machine with a platen, an angled platen.
So all of this are done by hand, by removing this part.
Yep. Yeah, done just so he's swedging in Singo blades, like our folding knife blade. So right here you can see he's just starting to rough out the swedge, and then he'll take it all the way back and finish it out. But
so he has to be very precise to make sure that it's consistent across all blades.
Yeah.
Nice. And this is Pacific, right?
This is Pacific right here.
Nice.
Yep. So yeah, once we have that swedge done, we're ready to sandblast it, and then it can go to coating. So that'll be the next step from here. And so we'll just go in this little room over here. This is Dodd.
Hello.
Blaster. Nice to meet you.
Nice to meet you.
So we can kind of see what the inside looks like. We use these Lazy Susan kind of fixtures so they can rotate. And then basically he has essentially a spray gun and big kitchen gloves. And then when he hits the foot pedal, it shoots 60 grit aluminum oxide out. When you're going to coat like fixed blades, or if you're applying a Cerakote, you want a little bit more of a rough sandblast because it helps the paint adhere to it. Right?
Yeah.
Then from there, once they're
this is the paint.
they're started, they'll go and come into the paint booth, and we'll coat Cerakote from there. So we got our different guns and my Cerakote guy's out this week, but we'll coat them up and then they go in the oven for an hour to bake at 300 standard Cerakote recipes. And then from there we'll inspect them because Cerakote. It's not Cerakote's fault or anything, but painting is painting, and sometimes you get a little speck in there. Things don't go great. If there's any sort of like flaw or something, it's not hard. You just re-sandblast it, paint it again, bake it again, and go. So when they come out of the oven, we'll do a very thorough inspection, make sure everything's good, and then they'll get sharpened. They can go get assembled up and go out the door.
Got it.
Yeah, fixed blades, at least on this side of the shop, is a pretty simple, just a couple of steps to go through.
So this is that new 5-axis machine. This is the actual main machine itself with the tool changer. And then we have a pallet pool that's still getting constructed. But basically I would have 12 different pallets or tables that can cycle into the machine. And so this will just be for bevel grinding, just doing the hollow grinding. So yeah, it's just kind of a mess right now. We're getting power hooked up. We're getting it all installed and all that. That's kind of it, man. Yeah.
How much is like every piece of machinery inside here cost?
There's millions of dollars worth of machinery in here. So like that new Mazak is I think we bought it secondhand, but I think brand new those are like 850,000 with the pallet pool and everything. Like the big horizontal, that's a $600,000 machine. We have over $1 million worth of it just in our like Swiss lathe department. So you don't buy it all at one time. You know, we've built this up over 40 years. Yeah, I mean, back in the day, my dad did a lot of it by hand. We had a very simple, like our first CNC machine way back in the like early 90s would just machine that hole pattern and like profile the handle. So CNC's been involved like for a long time, but we've been able to take over more and more different hand processes to make them more consistent, more accurate, higher volume. But we'll always have hand processes involved. There's just some things that you need that human judicial eye and kind of feel for some stuff. So that's where earlier I showed you like the hand grind room or the inlay team, that kind of stuff. You still need that hand finishing, but yeah, it's like we're always trying to weave technology in with our processes. That's how you grow. That's how you continue to stay moving forward. Yeah. We make a relatively modern style of product. Yeah. You know, it's titanium, it's machined, it's always kind of been like that, as opposed to say like Randall knives. We're good friends with those guys down there. A couple of years ago, my mom and I got to see the Randall shop. They're also a production shop, knife making shop. They're not a custom shop, but those are the process that they stick to is very hand done. They have like 13. I don't know if they're master smiths technically, but they're damn good at what they do. And they take each one of those knives from start to finish all the way through. And it's really amazing to watch like another production shop go about it in a very different way. So there's no like, in some ways, there's no right way to do it. I think there's just a lot of wrong ways to make a knife. But this is how we like to go about it. Again, we can get that consistency and I can make products one after another that are basically identical. And that's what we went about. The beauty, I think, in some of those Randall knives, for example, is even if they made like 10 of the same model, there's going to be a little bit of unique fingerprint to each one. And so like, but that's part of the charm of their product, right? So yeah, this is what we do.
Yeah, man. Thank you.
Absolutely. Thanks for coming by.